Hello everyone. In this video I am going to show you how to draw shear force and bending moment diagram using graphical method, and this is the example 3. So you can see the beam here, and there are two supports. C is a pin support and B is a roller support, and there is a point load at A, and all the lengths are given in this picture. The first step is to find in support reaction, but in this video I am not going to find support reactions. If you want to know how to find support reaction, there are plenty of videos in my channel. You can go and watch it. And here I mark the support reactions at C 6 Newton and at B 1 Newton. And in here I will draw shear force diagram, and here I will draw a bending moment diagram. Sign convention. So this is the sign convention I will use for loads downward positive. That means if the load acted downward, I will consider it as a positive force or positive load. Shear force clockwise positive, bending moment sagging positive. Shear force diagram. Okay, first we will draw shear force diagram. For shear force diagram we will use these two formulas. So this first one is ds over dx equals minus w. That means ds over dx means slope. This formula gives us the slope of shear force diagram, and it says ds over dx equals minus w. This w means distributed load. So in this case you can't see any distributed loads, so that means this w becomes 0. That's for slope, but it will not give values. For that we have to use this formula. It says S2 equals S1 minus total load between x1 and x2. So this formula is used to find values, not slope. Okay, we will see how to draw shear force diagram for this beam. This beam is started at this point A. So point A, you can see there is a 5 Newton force, right? So in shear force diagram is started at this line. Okay, if you have 5 Newton force at starting point of beam, this value will be 5 Newton. So I will mark it here. It can be plus 5 Newton or it can be minus 5 Newton. I will show you how to determine the sign of these values. And ending point also the same. So this beam is ended at point B. Point B, there is a force of 1 Newton. So the shear force diagram will be ended at 1 Newton force. So I can mark it here 1 Newton, and it can be plus 1 Newton or it can be minus 1 Newton. So these are the starting point and ending point, right? Okay, now we will see how to determine the sign of these values. So we are drawing the shear force diagram. So there is a sign convention for shear force diagram. So it says shear force clockwise positive. That means if we take the moment of this force about any point, about C or B, you can see moment due to this force is going to be this direction. So that means that is counterclockwise direction. So our sign convention says shear force clockwise positive. So moment due to this force counterclockwise, that means it is negative. So this is our value. That means I can delete this plus value. That's how we determine the sign of these values. At B there is a 1 Newton force. So I will take moment of this 1 Newton force about this A or C point. So if I take moment of this force, it will go like this, right? So if we consider the moment, the direction of this force is this direction, that means the clockwise direction. So according to our sign convention, clockwise forces are positive, or clockwise moments are positive when we consider shear force. So that means this plus value is the our value, so I can delete this minus value, right? Okay, those are the starting point and ending point. So now we will consider slope of these forces, or slope of this shear force diagram. It says slope of shear force diagram equals minus distributed load, so there are no distributed loads on this beam. That means it's equals to 0. That means 0 slope line. It simply says it's a horizontal straight line. So now I know the shape of shear force diagram or slope of shear force diagram. These both two segments slope is 0. So that means these two segments, there will be a horizontal straight line. Okay, now I know the value and now I know the shape, so I can draw shear force diagram for this beam. So this is a straight line and this is a straight line. So this is the shear force diagram for this beam. If you noted that we didn't use this formula for this problem because it is not necessary to use this formula, because we could determine these values from moments. So if we have a complicated problem, we should use this formula for finding values. Next we will see how to draw bending moment diagram for this beam. Okay, this is the clearly drawn shear force diagram. You can see it here. Okay, here also there are two formulas. So first one is for finding slope of bending moment diagram. So it says dm over dx equals s. dm over dx means the slope of bending moment diagram and this s means the shear force. So we already draw the shear force diagram, so therefore we can get shear force values from this shear force diagram. So this second formula for finding values of bending moment diagram, so it says m2 equals m1 plus area under the shear force diagram between x1 and x2. So we'll see how to draw bending moment diagram for this beam. At the starting point you can see it marked as A, and if we consider supports, this is a pin support and this is a roller support, right? This A point is a free end. Free end means there are no restrictions, so that means bending moment values of this point A is 0. So now I know this bending moment diagram will be started at this point, it's 0, and ending point you can see roller support. So roller supports do not restrict moments, right? So that means bending moment value of this point B also 0. Therefore there are no resistance for moment of this B or of this roller support. So now we know this bending moment diagram will be ended at this point, so that means it's 0. Now we will see shapes of this bending moment diagram. First I consider this segment, right? Okay, slope of bending moment diagram equals shear force. So if I write m as slope, okay, simple m, and MAC, slope of MAC equals SS means shear force. So if we consider AC segment, you can see shear force equals to minus 5. So that is minus slope. Minus slope means this kind of line, right? So I will roughly go here, I will show clearly drawn picture, and that is for slope of AC segment. CB segment, so I will write MCB equals shear force. So CB segment shear force value is 1. So MCB equals 1. That means positive slope, right? So it's like this. So now you can draw bending moment diagram, but still I don't know the values of this bending moment diagram. So I can start the drawing bending moment diagram. So for AC segment, AC equals -5. So this kind of line. So I know this bending moment diagram will be started at this point. So I can draw the line like this. So it's a minus slope line, slope of -5, right? So but I don't know value of this point. For that I can use this formula. So it says M2 equals M1 plus area under the shear force diagram between x1 and x2. I will apply this equation for point C. So I will write capital M C equals M1. M1 is the previous bending moment value. So I am considering this C point. If you consider previous bending moment value, it is 0, right? So I will write 0 here plus area under the shear force diagram between x1 and x2. That means area under this segment. So that means area of this rectangle. They are asking area of this rectangle. So we can calculate it. This height is 5 Newton and this length is 2 meters. So I can write -5 because here minus sign, -5 times 2. So it comes -10. Units are Newton meter. So this value is -10. Now I know the value, and now I can draw the other part. So I know the shape of the bending moment diagram. So I know the ending point. So I just have to draw this line. Also you can check this value. So I will apply this equation for point B. NB equals M1. M1 is the previous bending moment value. I am considering this point B. Previous bending moment value is -10 plus area under the shear force diagram. So they are asking this area. This area is this length is 10 and height is 1. So I can write 10 times 1. So you can see -10 plus 10 becomes 0. So this value is 0. So this is the bending moment diagram. So I will show clearly drawn bending moment diagram. Okay. This is the shear force diagram and this is the bending moment diagram.